All right. Hello, everyone, and welcome to this live stream masterclass. I got to say, I'm super excited about this one. Usually, I'm stressed about webinars and masterclasses, but I'm the least important person here tonight, so I kind of have the easiest the easiest job. But we're joined with some fantastic guests here. We have Bill Hammer, who's joined us before. Bill, you're the CISO of Supabase. Could you say hello? Maybe introduce yourself to everyone out there today.
Sure. Thanks for having me, Mackenzie. Great to be here. I am the CISO for Supabase. Been with the company 10 weeks now. Former CISO for SuccessFactors, Zscaler, Good Data, Craft Ventures, and so on.
And we also joined with Etienne Stalmans. Etienne, thanks so much for being here today. Maybe could you give a quick introduction to yourself, your role?
Yeah, so Etienne, I've been with Supabase for about a year and a half now. Started off as a security consultant more than a decade ago. And for my sins, I moved into blue teaming, and now I'm working with Supabase. Before that, with Heroku, Salesforce, etc. Pretty used to the security thing by now.
Yeah, perfect. I like that, for your sins. You can go, you can go there. But we're thrilled to have you there. A year and a half in Supabase, it must be equivalent to like 5 years in any other company, because like just of how like rapid you guys are progressing at the moment. There's been some wild news. I'm not going to go into it, but it must have been quite the journey over the year and a half to see it all evolve.
Yeah, it's been crazy growth, but very controlled. I'm really surprised. Normally when things go so quickly, you'd expect it to be uncontrolled. And yeah, it's just been planned, amazing, fantastic team who thinks about security and performance first.
Yeah, perfect. I would expect nothing else but a controlled acceleration into the internet universe. I want to kick things off though, just for the audience here to kind of know what to expect from this masterclass. We're actually going to get into the technical weeds of Supabase a lot. So we've really aimed this for people who are kind of actively using Supabase, interested in Supabase, people that are maybe concerned about security for something, if they're vibe coding or if they're deploying on Supabase in a traditional way. So Etienne has agreed to do a lot of demos for us, so it's going to be pretty technical. But I do want to start off with maybe a couple more just kind of high level questions here. And Bill, I kind of want to throw this to you, to those listening that may be like considering why is Supabase kind of, in your opinion, kind of an obvious choice for what we could consider kind of next gen applications, and kind of the serverless style of deployment?
I think it's a great question. I think it's because we've built it out from a developer's point of view to start with. Like that is our ethos, is to be built for developers. If you think back to the days of Oracle with stored functions and Oracle forms running, that was not developer friendly. It was a bit of a nightmare running stuff like that. And I was running those back in like 04, 05. Being able to bring together the necessary functions, the edge functions, auth, RLS into the database, because everything is about the data. So why are we building out, secondary layers? Why not just collapse it all into a single place, build your front end, and then control everything on your back end? And that's, I think, really why it's the next gen for what we're doing. It's simpler, less points of failure, and definitely integrated functions that work.
Yeah, no, I do like that, and the whole like concept of Supabase, as I've been like discovering into it, is as you say, it's starting at the data and controlling even security from the row level of the database, which we're going to get into.
Yeah.
I won't get ahead of myself. Etienne, you're a security engineer. You've just kind of talked about your background a little bit. I want to ask a similar question, but strictly from a security point of view. Like, what security benefits does this serverless approach that Supabase can offer, what does that actually kind of bring to the table? Why might that be kind of a good decision from a security point of view?
Yeah, so for me, it's the change of mindset that it brings about. So it's a data first approach to security. and the way that you're building out your product. So when you're looking at your traditional security model, you normally build in your backend and you think about where I'm going to store my data. And then you think about your middleware and all the services that connect to it. And you think about applying security at that level. And you have your incoming request, then you go make a request to the database, you get the data back, and then you make a security decision. Should this user have access, yes or no? When you move this layer into the database itself, or very close to the database, you start thinking about security from first principles, from the moment that you're putting data into the database and going, what are the relationships that exist between security and my data? Who should have access to it? And how can I model the application I'm building around this principle of security? And that really changes the way that you approach building your product. But it also, once it clicks, you speed up in development and you're able to develop really quickly, but also have that certainty that you're doing it securely.
Yeah, I do like that. It's a change. Like, as someone, I started experimenting with Supabase like because I was experimenting with some like vibe coding tools like Lovable, and it's a little bit of a change in your mindset, as you say, to get it. And at first it kind of can feel a little bit like frustrating, but then once there is a click, once that happens, it just feels so obvious to me. Anyway, I don't want to sound like too much of a fanboy, though, to be honest. I'm here to be critical, so I gotta rein it in. I gotta rein it in a little bit. I wanted to kind of go through. We're going to touch on a few things in some technical tool weeds, but we've been discussing about this, and we've kind of come up with some things that we think is most critical to learn. Now, when it comes to deploying on Supabase, there is some first things that you can do, and it is a deep platform. If you really want to get into nitty-gritty of things, what you can do is fairly substantial. But these are kind of the things, not to overwhelm yourself at the start. Is if you're going to understand a few things for security, this is what you should. So I think the first part is understanding how authentication works in Supabase, that we're going to go through, kind of how your like database is connected through that. And then I think, for me, the most like the thing that security is all built on is understanding row level security. So we're going to go through kind of some of these and step by step. But I want to start off with kind of the users and the API, because there's more or less, when you look at it, three users that we have here. Two that you probably are going to use it, and one, let's say, God user that you can test with. But so the kind of two that you are basically unauthenticated and authenticated. Kind of simple, boils down to that. So kind of before we get into it, and Etienne, I know that you have kind of a demo that you can kind of show, it's kind of explaining this a little bit. But first of all, Bill, I wanted to kind of ask you, from that point of view, there may be people looking at this going, my application needs way more user control or different levels of that than just two users. Can you kind of walk us through why there's only two, like at a high level point of view, and how that works? And let's say a very complicated app that has multiple levels of authentication within it.
Sure. And this is I think that thing that Etienne talked about, where you have to get your mind to just step a little bit to the side and look at it differently. If you think about data, there are two states of it. You're either allowed to do something or you're not allowed to do something. Those are your two. And so when you look at authentication, an anonymous access is given an ability to do something. It's typically read. It could be an update in some cases, though you're going to have to figure out how that fits into your path, but I'm going to go with never. So it's usually a read. So I need to read something, and the system is allowing me to look at or read something from an anonymous perspective. If I need to do updates, all updates on data have to be logged. There has to be who did what, when, why, and was it appropriate, right? And that is authenticated. So you have the anonymous for the light touching of early stage stuff, and then you have your actual authenticated. Once you're into authenticated, You need to be specific about what you authenticate, what your authenticated user can do. If you look at the old days of doing table segregation for multi-tenancy, right? You put them in fully qualified SQL statements to a specific set of tables. That's not really authenticated, right? That's controlled, but not authenticated. So you've got access to this entire table, and then you would look at the middleware to try and add those authentications on to say, yes, you can look at this user, but not that user, or this bit of data, but not that bit of data. We're taking that piece out and just saying all of it absolutely needs to have authentication on it, so you don't have to worry about trying to segregate things off on tables. You're doing it at the data level. End of story. This bit of data falls under this control for this authenticated user, and they can do this, this, and this with it, or the others cannot. And that's why when you make it as simple as that, and you step back and take the complexity that we have spent probably the better part of 20 years building in, it works way better. It is much more simple because it is secure by default. You turn on row level security, you can do nothing. Now go start adding what you can do and be very specific about how you do it.
Yeah, no, I do love that. And I think, yeah, this is definitely part of that shift in taking about. Strip it back to the beginning. You can build very complicated systems on there. You can have all different types of users inside your application. But at the end of the day, you either can do something or you can't. And that's essentially. Etienne, can you show us kind of this in action, and what this kind of looks like within Supabase?
Yeah, sure. So I'm going to share my screen. And to go back to what Bill said earlier about being able to build quickly through this model, this is an application I quickly put together this afternoon using Lovable and Supabase. So we've basically got a tortilla de patatas sharing website where you can go share your recipes and you can view these recipes. You've got private recipes, you've got public recipes, and public recipes can be viewed by everyone. Private ones can only be viewed by people that you share these with. So this is a perfect use case where the idea of anon and authenticated comes in. So the anon authenticates the request coming into your database, and that ensures that all the requests that actually make it all the way to your backend have been authenticated at some level. So it prevents the kind of drive-by attacks where you've just got web scrapers who are trying to get onto your API and get all the data. But it's not aimed at keeping the data private. It's just authenticating that the request coming into the database is a legitimate request. So what that looks like on the back end, if we go into Supabase, so we need to set.
Could you zoom in a little bit on
yes,
your that'd be great.
Yeah. Okay. How's that?
Perfect. Yeah. Thank you.
Perfect. Okay. So how that looks on the Supabase side is you are able to set these row level security policies on your tables. And what this looks like, again, is a bit of SQL. And that SQL will tell you what is allowed to be done, what action is allowed to be taken, and by who. So you can set your policies on the standard CRUD operations in Postgres, your create, read, update, delete. And you can set it to anon or to authenticated, or you can also shortcut it by just saying public. So anyone that comes in needs to, this policy applies to them. So in this case, we're saying anyone that comes in with the anon token or with an authenticated access token, they're allowed to see anything that's visible public, okay? So that's been set. What that looks like on the backend side is, I'm sorry, I don't know if I can zoom this one in. I haven't used Burp in ages. So let's make it bigger. Okay, I'm going to have to apologize and say I can't zoom in. But basically, what I'm going to try and highlight is the differences that you see. So with the anon requests, you've only got this API key coming in. So that's just authenticating that this request is allowed to come into the API. With an authenticated user, you'll see there's also an authorization bearer where you've got this JWT or JOT that provides more information about the user that's making the request. So if we make it as an anonymous user, you'll see we get back this one record because it is a public event, it's a public recipe, it's allowed to be seen by anyone that's got a none. If we come with one of the users that has a bearer token associated to them, and we make the same request, here we can see we get 3 recipes. Because this is the owner of the recipes, they can see the ones that have visibility private. So that's the main difference. The way the backend makes this decision is based on this bearer token that comes in. This chart contains information about the user that is making the request. And that allows us to create these row level policies that say whether it's allowed or not.
Yeah, no, that's perfect, and it's really clear. And I think even you know, like even zoomed out, you can see, because I think we're familiar with bearer tokens, we're familiar with that. If you haven't used Burp Suite, also have a play around with that. If you're listening, it's a great tool to kind of test security, and it's a tool that you can kind of see what people can do outside of the buttons or the forms that you've allowed on your front end. But you've given us a great introduction here to talk about something that I really want to capture here. And I decided, because I asked a lot of both of you in preparing things for this, I decided that I was going to prepare something myself, give myself a little bit of a test here. So what I thought I'd do is I'm going to try and explain row level security in the way that I'm understanding it. And then I want to know if I've got the concept correctly. So this is the one part I'm stressed out about of the masterclass. But let's give it a go. How I kind of think about this is, if we have our application, like we're using our application, within that, in a standard application, the way that I think about it, we have some authentication going on here. So let's say that we have user 1 here, which is this first row in the database, and this is what we're authenticated into. And how I see information from user 1 in a standard application is that there is logic that my application, that I've written into my application, that only allows me to see users 1 information. However, the application itself has access to everything. So if a malicious user is able to convince someone that actually I'm not user 1, I'm admin. So maybe I'm using something called IDOR, it's like indirect object referencing. It's basically, the easiest way to think about it, if you've got a URL bar, I change the ID from 1 to 2. And then I see information because the application has access to everything, I then can do it. So I have to make sure from my application that I write everything super strict and super well. And then if we take the idea of like a vibe coded thing, this gets quite complicated, because maybe you're not thinking about it in this way because you haven't written it. A tool has written it for you. All right. So now that's kind of regular. I want to kind of talk about how I think about row level security. So, this is the example that we can see everything. If we change it to row level security, it changes it. So instead of authentication, the app being authenticated into the entire database, it's kind of the app or the user session that is authenticated on a row by row basis. And how I think about that is, if I'm able to trick the application into the fact that I'm an admin or I'm a different user, it doesn't really matter, because the data that the application can see is only for the user that is authenticated. So this is how I'm thinking about it. So, and you can't access everything else, because it's kind of looking at security on a row by row basis. So, Etienne, I want to ask you, how did I do in my description? Did I get it right, or am I missing some concepts?
No, you got it right. You can literally think of row level security as a filter. There's a filter that's going to be applied when you make a select statement on your table, and that filter is going to be applied on every single row. And once you've set your policy that I only want the user IDs to match on a specific column, that is what Postgres will actually allow through. It will only return those rows where that statement is true. So it's very similar to doing just a raw SQL request, where you say select all where user ID equals 1. In this case, Postgres is doing it as a security check. It will say, I'm only going to return where user ID is 1, regardless of what your where statement looks like. And that's the benefit. One of the major benefits of doing it this way is you can get it wrong in SQL, But because your row-level security policy is enforcing that paradigm or that data-first security model, that data doesn't make it out of the Postgres database and to the front end.
And if you think about this in the real world, think of it like a bank vault with safety deposit boxes, right? Everybody's allowed into the vault. I can go in there with a manager, and the manager's key will fit every single box, but no box will open until my key goes in, and only mine goes in, right? And only mine opens the one I have access to. And that's the added layer that we've created here.
Yeah, that is such a good analogy. I'm kicking myself that I didn't come up with that, because now I'm thinking much better way to explain it. Maybe I should have asked you before the webinar. That probably would have been smart.
I have explained stuff like this to executives for 2 decades, and I find that the second the word SQL comes out of my mouth or a technical term, their eyes start to glaze over. So I just find real world examples where it fits.
Okay, so Bill, let me ask you this then. Like we've talked about somewhat of the benefits of row level security. Why, in your words, then, do you think that this is the correct solution for I'm going to continue with my term of next gen apps, because I think that encompasses a lot of things, and I want to do this with the framing that I know that this is secure, but it's also true that I can make an application in other ways without row level security secure as well. Equally as secure in very different ways. So why pick row level security over a more traditional authentication method? Go.
True zero trust. The reality is, if I set up data and then I tell someone, go build me a middleware layer that's going to enforce the security that I need, and then I allow that middleware full access, but say pre-filter it, I have to trust that it gets it right every time. If I go in and I touch every bit of data and say, this data, here's the permissions, I have reduced the risk of error exponentially. I've also introduced some other areas where there is risk, and this is why we are so adamant about RLS being turned on, and why I say this statement now more than ever. Just because it works does not mean it's production ready, because a lot of vibe coders will be in there doing their vibe coding, getting stuff right. And I'm guilty of this myself. Like, we're all guilty of it, because we need to fix things. We need things to work. And I think every vibe coder out there at one point or another has said to the AI, just make it work, because they're hitting a problem. And just make it work could mean, hey, turn off all security, right? Like, it'll make it work, whatever it is you want. So just because it works doesn't mean it is production ready. And that's what we're now teaching. We're teaching this new way of, you are the data custodians. Your responsibility in architecting this is the security of that data. And by security, I mean the right access at the right time for the right reason under the right conditions. And that is what row level security requires.
Yeah. I totally get it, and it's so true too in what you're saying. And when I was like vibe coding, I had this exact scenario that you were talking about it, and I really think at a human level is that I was getting an error, so I asked the vibe coding application to solve the problem for me. And it doesn't matter what application I was using, because it's something to do with like how AI systems work. And how it worked is it did what a human would do. It removed all security to see where the problem was. But then the system had achieved the objective that I told it to do, which was to make it work. So therefore, it's now, it's a tick, like, and what it done, and it deleted all row level security policies, but it worked. Right. And this is, and I love the fact that in the row level security, you can start with just deny everything and then peel, add layers of authentication. Don't
be conscious in how you give access, right? This isn't just, let me figure out what I shouldn't do. It's, I'm giving nothing, and I'm going to consciously make decision to allow Etienne to access this data. I'm going to allow Mackenzie to access this data. I'm going to allow the world to access some piece of data. And when you make those conscious decisions, you start to approach it much differently. And that is also when you're doing anything in AI, if you trust one AI, I'm going to say you're kind of crazy. You want to at least use 2 AIs, right? Look for different opinions. 4 AI principle, I guess. But the reality is you can use a vibe code and you can build it, and then you can literally go over to your Supabase account, and we have our own advisory checker that will go through and say, hey, FYI, you've turned off row level security, and you can turn it back on there, right? You can make sure, and we're putting those interfaces between the Lovables and the Vercels and those of the world, so that way they are exposed to it and they see it as well. They can tell you, hey, FYI, you've turned off row level security. You now need to turn it back on and start to, deal with any issues that you have at that point.
Yeah, I will say that when this happened, it was before those updated. It'd be pretty hard. It'd be pretty hard to ignore all this.
Yeah,
Now
I think we went from a
Supabase.
little lock, we went from a little lock that was open to a word that says critical. And I am advocating for that word every week that word critical is there. It should get bigger and bigger and jiggle and turn red, because you do not want to expose something that has
it should
row
look
level,
like Jen's
unless you
computer
consciously made that
from
decision. And I can't think of any reason why you would ever say, I don't want row level security. I want row level security that is open to everyone, is a conscious choice, versus I have no security turned on.
Yeah, absolutely. So we've talked a lot about row level security, and we've briefly touched about the rules that it is, but Etienne, I want to kind of hand it back over to you. Like, what is the difference in policies? How do you write these policies? Can you show us, in Supabase, how this actually looks like in real life? Look at that. He's already, I don't need to prompt him.
Let's get the right screen up. Here we go. Okay, so just get back to the system that we're using, or the application. So in this case, we've got the recipes table with all the recipes that are owned by a user, and that can be public or private. And then I mentioned they can share a recipe with another user. And this is defined in this recipe shares table. So again, this is where we're starting to think about our data. How's it interconnected? And here we say, I'm going to share it with only this user. Now, the way we've set up row level security in this case, so go back to the recipes table, row level security, we've got two select rules here. We've got one that says public recipes are viewable by everyone. And that's the one I showed you earlier. So it just says, any time that the row contains the column visibility in that row is set to public, this is allowed, filter this and allow it. However, we've also got another rule that's saying whenever we see one that is private, a column that exists with private, and we check, does a share exist? So this is a common mistake that we see, and this is one the AI actually made. So I just used the example directly from the AI. It went and said, okay, select one from the recipe shares where the current user that's making the request has an entry that is shared with it. So what this means, it will always, as long as that person has one recipe shared with them, this whole statement is going to return true. So effectively, this means visible, private, and true, or for every single row, because this second statement is always true, right? So what that leads to is that this is the legitimate user that owns these three recipes. It can see all three recipes. But this user that's supposed to only see the first one and the second one, because this mimosa is shared as a private recipe and La Bomba is a public recipe. So it should be able to see that. So that's one of the common mistakes. To fix that, what we need to do is just look at our relationship a little bit differently. So what I've done here is I've got, this is the bad policy. You see it checks exists. Here's a better way to do it. So we still use exists, but for every row, we also check if that recipe ID is matching the recipe ID of the shared instance. So if we select that, we apply that policy. So now if we go back to the legitimate user, they can still see all three recipes because they are the owner, and the attacker, they can only see two because it's automatically filtering out that recipe they don't have access to. So that's another benefit of the row level security, right? Now I haven't made any application change. I've just changed the way that we reference the data, and we are able to control what data comes back. We don't have to change any code that says, okay, we've now got all the data back. Let's filter on what this user is allowed to see. The database controls that for us. However, sorry, go ahead.
No, I was just going to say how powerful that is to control it in that way, because like the more simplistic you can create your security controls, the less risk you're kind of introducing. And it doesn't get much more simplistic in terms of be able to control users than at that rule base at the high level.
Yes, exactly. So one thing that this version runs into is this doesn't scale very well. So as I mentioned, row level security is applied on every single row. So this select statement is going to be executed for every single row, because the way that the Postgres query planner works is it checks if a specific statement or SQL statement is cacheable, and if it can store the result for that and reuse it, or if it's a mutable statement, it's going to rerun that every time. So as our table now starts growing, this is going to get more and more expensive because we keep calling the select statement. So that's another foot gun that sometimes comes up when we're starting out with row level security policies. So the way around that is to just use a function. So you can define a function in Postgres as something that's stable, meaning it will always return the same result. And if we do that exact same thing, we just execute these two. It's going to just make that query do the exact same thing. It's just going to be a lot more efficient.
Yeah.
Yeah.
That's super cool. And the one thing that I always tell people that are kind of in this is that I know it can be overwhelming if you've joined, and especially if you're kind of vibe coding. There's so much to learn to understand of it. But if you can learn and really understand row level security, if you're using this, then you're essentially going to have a lot more control over the security of your application. And this is it's very manageable. Understanding security in a traditional sense is very unmanageable. That's the reason
I think
why
that's been proven over the years.
yeah. But it's so that, and I think that demo kind of really proves that. I've got some difficult questions now, especially for you, Bill. So I found out I was doing my notes in here, and I thought you guys had 40,000 users. You have 4 million users, so I was off by a factor of a lot. So I have a question for you, and that is that Etienne mentioned briefly in their scalability. So how scalable is row level security? And I guess the ultimate test is at Supabase, do you use row level security? Because you're the ultimate kind of test for scalability of this thing.
And 10 weeks into this gig, I'm going to let Etienne comment more on this. Yes, it's scalable. It is absolutely scalable. I have seen 0 reports of scalability issues on row level security from even our largest customers. How we use it, I have not gotten that deep into that side of the house. So I'm going to let Etienne do it because this is his world, and he does it very, very well.
So yes, we still use row level security. Everything that you do on the Supabase dashboard through the management API, through CLI, that is all gated by row level security. We've got some pretty advanced row level security and some really complex checks. And we've taken it as far as the middleware, where we need middleware, actually does just a request to the database, calling the row level security functions that we have to check if a user has permissions on a project, on an organization, etc. So without having to build that into code, we still do it in the database. In your traditional web app where you do have a middleware, you would have to make that database call anyway to make the security decision. Here, we just make it to a database, make the security decision, allow the request, and then use row level security again. So it's executed twice and no scalability issues.
Yeah, and there's the purpose behind my my question here is that obviously as you grow, things get more and more complex. That's it. But one of the indications is, you don't need to build an application for 4 million users immediately. But it is nice to know that what you do build, you can build upon as you grow and not have to rip out and replace it with something else. And so that's kind of like nice to know that even though, yes, it's going to get complicated, but that's a good problem to have because it means that your application, whatever you're building, it has traffic and is being used and utilized, but you can scale it to a point. And I think that Supabase activity and users will be in the very, very minuscule percentile of kind of applications out there with large user bases. So I think we can well and truly say that, yes, it's going to it's going to work. I do want to be devil's advocate now because no system is perfect in every single use case, right? And we need to acknowledge that. And it's there are other options out there. Well, is there an option that row-level security might not be a good use case for an application? Is there a reason kind of to start looking at different parts, and what would be the indicators of that?
Wow, that's a good question. I guess you would be looking at something. I can't think of it because to me, having no row level security means you have no security, and nothing should have no security. You can have
Yeah.
minimal security, but you should be validating everything that comes in, at least to the lowest common. You could probably do it somewhere else, I guess. You could build your logic in somewhere else, but you're going to build your logic. You have no choice.
Yeah.
Even a free, open, like Wikipedia is free and open, but it still has security on the data because even if you look at, ignore all the edits and update side, the read side, you're watching what's coming in because you want it coming from a reputable source versus, I don't know if they're blocking the AIs yet, but maybe you're at least going at that point going, yeah, it's free, but it's not totally free. And if it is totally 100% free information with no control on it, what are you doing with it? Like, why are you there, right?
This is the correct answer, Bill. And the reason why is my next question is when you're in the infrastructure. Let's say that I'm someone in a company. How do I convince, and especially management, like about? I think the demos that we've just done and what we've discussed can convince a developer about row level security and about it. How do you convince the team to adopt this new method of security for the next gen? How do you convince the upper part of it that serverless row level security is secure? It's the way to go.
So I would say, first off, any developer out there that is looking and thinking, how do I make security for what I do better? Good, thank you. I support you. I will support developers in those cases to the extent that, as a CISO, if they bring me a solution that they say, hey, this makes it more secure, and they show me and prove it and explain why, I'll buy it. Like I have spent decades trying to shove security solutions down developers' throats. And that was my job for a long time. And it's brutal because developers build, and they're usually subject matter experts in what they're building. And to disrupt that flow becomes very hard because they don't produce at the level they used to, and they start to second guess and they have to go back. So I look for any solution where a developer says, hey, this makes me better. Great, let's talk about that. I will listen to any developer that says this makes me better, and here's why. So I think you will find it very easy. It may not be as simple as row level security is better than our middleware security layer. But I doubt there's a CISO out there that would say, no, I disagree, it isn't. Because we all realize that the controls are coming closer and closer to the ends, to the points. We see this in just general security architecture as we've migrated from on-prem corporate environments through to work from homes. We are pushing more down to the endpoint. We're doing the hyper-converged endpoint. We're doing the edge. We're bringing the functions closer and closer to the places where they matter. And that security is rolling out of the middleware down to the data layer is just natural evolution. There is I don't think there's anything unnatural about this. This is where it belongs. Because as long as you're close at that last decision, right, before you turn that second key in the safety deposit box, does the key work? It does. We've done everything we can at this point. Maybe we've given the key to the wrong person. Now that's a decision that has to be made and dealt with. But I think coming to that realization and taking it to management, going up and saying, look, data is where the lifeblood of the company is. This is how we make our money. This is how we function and exist. This is why we're in business. We need to put that security as close to it as possible so there's less chance for a fuzzy error, right? Put it at the middle layer, but still have that application have full access to all the data. Now you're relying on the logic of the application and the code there to not be compromised, not be manipulated, not be tricked or fooled, or simply make a mistake and start pulling too much data. If you don't allow them to pull too much data, you're better off. It's like the old days when we used to pull everything to the browser and filter in the browser, right?
Yeah.
Just not saying that we ever did that, but I've heard earlier companies did stuff like that. And then we brought in the middle layer, right? So we've gone from the front end to the middle. Now we're into the back end where it truly belongs.
Yeah. There's a lot I could comment on there, but I'm conscious of time. But the one thing that I'm taking away from that, Bill, that I'm going to use myself is you said this, we want security as close to the data as possible. And I think that is like a very powerful statement that is very difficult to disagree with if you're anyone. So if you're struggling with that. There are some questions coming in. I want to get through kind of what we had. So I want to continue on in the next part here, and I will try and get to the questions as we get. I'm conscious of everyone's time here. Etienne, I wanted to ask you this here. How do you audit security? What can you do in Supabase? You've built an application that's out there. How do you know you've done it right? We've talked a little bit about flashing lights and cautions, and hopefully those buttons will grow larger as we get going, as Bill said. But what is available at the moment for you to kind of audit your security in your Supabase applications?
Yeah, so one of the arguments we hear often is once you move the security into the database layer, how do you can't do security audits. You can't run unit tests, you can't do integration tests in terms of security. That is false. You are able to do these tests both in your development environment, and you can actually run safe tests within your production environment and apply what I've termed continuous assurance. You can continuously assure that what you're saying is the security state of your data, of your database, is true. And I'm going to show you how to do that now. So what you had there on screen, you mentioned pgtap. So pgtap is a Postgres extension that allows you to run these kind of tests. And what you basically define is, I want to run some tests. So I'm going to run 5 tests in this case. And in the first case, I'm going to select all the policies from this public schema on the table recipes. And I expect there to be 5 policies that are set on this table. And those policies should be named this. If my test comes back with more or fewer policies, it means something is wrong. And in this case, I'm going to use Supabase test DB, which just runs against your local DB, but you could also run this against a remote database, and it will do the same thing for you. The next test that I'm going to run is you can just change your role to the Postgres user. You mentioned the service role key, which has bypass RLS permissions, the Postgres user as well. So if you just connect directly to your database, you bypass the data API, you've got this Postgres user that can do anything. And in this case, I'm just going to select everything from the recipes table, and I expect 3 values to come back, and it should return true for all of those. Next test, I'm going to change my role to the anon. So I'm not permitted to get access to these private recipes. And in this case, I expect there to be only 1 result. If more than 1 result comes back, it means that my RLS policy, this one, public recipes are viewable by everyone, is incorrect. It is allowing more than what I wanted to allow to come through. Next test, here we set our role to authenticated. And as you mentioned earlier, you've essentially got two authenticated states. You've got a non and authenticated. When you've got the authenticated request, you come in with that JWT or that JOT that has a bunch of claims in it that verifies which user this is, what role they have, etc. And that's what we can do in our test. We can say that incoming request, it has this claim said that the user ID is this UID, and we expect that user to be able to read all the recipes. Then we can switch to another user, and we only expect 2 results to come back. So if I run Supabase test DB, you can see, whoop, it failed, and it'll tell me exactly where. It says, oh, we failed because we only want to return public and shared. So to only public and shared, it returned an extra 1 instead of La Bomba and Mimosa. So to fix that, we can just apply our altered policy. And if we rerun this test, did I apply the right one? No. Demos.
I still am very impressed of how you're doing all of this live, because we talked about, do you want those or can you do it live? And you said, I want to do it live. I was like, okay, bold choice. You've been doing amazing.
And there we go. So we applied the correct policy this time. It will come back as passing. All the tests have passed. Now we know with confidence, if we want to push these changes into our production database, we know that the new updated policies will be correct, and that migration will ensure that our data is safe in the production one. And as I mentioned, you can also run these tests continuously and make sure what you're expecting to be deployed in production is actually remaining untouched in production. No one's messing with your database, no developers doing something outside of this authorized flow, etc.
Yeah, I think that's super cool, and it's so nice to have these. And what you say is true. That I think like a little bit of pushback is that you can't do unit tests, but I think this goes back to the same: is that this requires a change in mindset, and you can do everything if you change your mindset to it. So that's cool. Awesome that you've been able to show that. I wanted this to be 45 minutes. That was way ambitious. We're already over, but we are going to wrap it up. There has been lots of questions in here. We'll have to come back to them another time. Maybe we'll do just 1 or 2. We have here that one of the polls, there's many polls in here, has said that he's having trouble trying to get their developers on board to kind of use rollover security because they think that it's too difficult to apply to the database. Etienne, this one's probably for you. Like, what would you suggest to try and get developers on board with that kind of merger and changing that area?
Yeah, so security is always a compromise, right? And normally you're looking at security or you're looking at performance. And that's kind of the selling point that you can take to developers in this case, is that row-level security can help you improve your performance of your application. Because you're moving those checks closer to your data, there's fewer round trips to your database, and you've likely got better performance. The other thing that row-level security enforces is that you think about your data. And that means that you normalize your data structures so that you have better data relations. One thing that happened to me today, I was working with these tables, the shared recipes and the recipes table, and I created an RLS policy, or the AI created an RLS policy that led to recursive function calls, and that just was a mess. It was performance heavy, it didn't work really well, it just failed the whole time. So it made me rethink about the way the data was structured. We're able to normalize the database, and now we've got a more performant database going forward, etc. And then the other one is just the testing that I just showed. You've got the ability to create these tests that positively prove what you say is the state of your data is the state of your data. And that just goes very far in preventing accidents in production, accidents in development, and a big fine at the end of the day when someone steals all your data.
Yeah. One more question, then I promise we will wrap up. Bill, this one's one for you. you joined Supabase not so long ago. So this one is kind of like a bit of a personal question. What was the point that you were convinced on row level security? You have a long background. I'm sure you had to be convinced of it. What was it that sold it for you?
It seemed like such a natural evolution. So when I go back and think about handling success factors, we had 24 million users. We had, data centers all over the place, and we were running standard databases on the back end. And the programs I put in place, because to me, when you sell HR data systems into Germany, for instance, in the mid-teens, there was a lot of focus on privacy of it. And so my belief is that, and I know a lot of people think I'm crazy for saying this, security isn't a thing. They're tools. Security are tools. That's all they are. And they're tools that anybody can use. We are here to control the dissemination of information, correct time, place, condition, etc. And as a developer, and I've seen developers all over the world grow and build more secure by design systems, are now building privacy by design into the systems they build. And row level security is the piece that unlocks privacy by design, because as Etienne said, it makes you think about your data. It makes you think about why you're accessing it. And that's why we hire an HR programmer to build an HR system, because they have such depth and understanding of the subject matter that they understand the nuances of perhaps a German employee should not be seen by a French HR person or an American HR person. They have to build that in. And if they can build it in at the data level, not the logic that gets them as the code is built, the logic that takes them there, but literally they can write the logic to do the query, and then they can say, okay, I am going to lock this data down to this profile. It's so much simpler. It's so much more effective. And then they run those tests every day, every 5 minutes, every 30 seconds, every update, whatever it is. And they are reassured, and then they know what is happening in their environment. It gives them a bigger ownership of what's happening. And I think a lot of developers would like to see that. They'd like to be more in control of how they build an application, not just the lines of code.
Yeah. No, perfect. We are going to have to wrap it up after there and get to it. I really want to thank you both so much for coming on the stream. I hope that people watching this can actually appreciate how rare it is to get this level of person insane enough to come on a webinar with me. I'm not actually sure why you agreed to it in the first place, but Bill, this is the second time you've done it. So at some point, you just have to start questioning your sanity. But
been questioned a long time ago.
But I really so thrilled that you're able to share this with people. I think it's really important conversations and to have and to share, and for everyone listening that wants to know, what do I do next? Well, I've got good news for you. Supabase have developed some really cool resources. They're working on new ones. So you're going to get a follow-up email that you've attended this webinar. It's going to have the recording of the webinar. There's been a bunch of questions about that. It's also going to have some really cool things like a capture the flag that Supabase did, and some other resources. So don't worry, you're not going to be left on a stranded island. There's going to be resources for you to kind of work on this that I'm going to share with you in a follow-up email. So stay tuned for that. Etienne, Bill, so much. Thank you so much for coming on here. I certainly loved it, and yeah, and if you're still crazy in a few months, I'd love to have you back. But well, I won't push my luck too much now. But thanks everyone. Thanks for tuning in, and we'll see you all on the next webinar.